Hello there, Mr. Sutton here, bringing you this lesson on the elimination method. In this one, we're going to solve systems again, still algebraically, but instead of substitution, we're going to use something called elimination, which you might also have heard called linear combination. Either way, we're going to use it. For the warm-up on this one, I'm giving you two systems of equations below. I want you to just add each pair of equations together to get another single equation. Pause the video, give it a shot. Alright, so for this first one, basically when you're adding equations together, you have to combine like terms on each side of the equation. So on the left side of the equation, we have a 2x and a 4x getting added together, so that's 6x. And then 3y minus 7y, or plus negative 7y, that's negative 4y. And then on the right side, we have 10 plus 14, which is 24. Now it's important to note that we can only add the x's together because they're on the same side of the equation. If the 2x is over here but this 4x were on the other side, we would not be able to combine them. But beyond that, nothing really special happens. We just get another equation with an x and a y. Now let's try this one out. So here we again get 2x plus 4x giving us 6x. But 3y plus negative 3y, well, those are opposites, so those are going to cancel out. And then we still have 24 on the right side. So this is a different situation. We'll notice here that we have actually lost one of the variables along the way, and now if we wanted to, I mean we weren't asked to, but we could solve for this single x value if we wanted to. So this brings up the question, if we want to solve a system, when is it helpful to add the equations together? Pause the video, contemplate that one. So looking at these two different situations, it's more helpful if you have this situation with these opposite-like terms here. If you have opposite-like terms like 3y and negative 3y, adding equations together will help. If you don't, then adding equations together won't really help you much. So here's our first real example. On this one, they want us to solve using something called elimination. See if you can use what you just saw in the warm-up to actually solve this system of equations. All right, so in the warm-up, remember, we added two equations together and it got rid of one of the variables. Well, here we notice that if I just go ahead and rewrite this first equation under the second one here, just so it's a little bit easier to add together, and I actually add those together, let's see what happens. 7x and negative 7x will cancel out. I've got 2y plus y, which is 3y, and then I have negative 1 plus 10, which is going to be positive 9. So that immediately gets rid of one of my variables, which is kind of that golden situation where you're actually able to solve the equation. Now that we only have a y left over, let's divide by 3 to get y equals 3. And now, just like with the substitution method, we can plug this y value back into one of the equations to solve for x. So doing that over here, you could use either one, but I'm just going to go over here. That's going to be negative 7x plus 3 equals 10. And then if we subtract 3, that's going to be 7. Dividing by negative 7, we have x equals negative 1. So our answer then just comes out to negative 1, comma 3. Now, one important question to ask is, yeah, this did some useful stuff, but is it actually legal to add equations together in order to solve them? Turns out it is. You're allowed to add anything you want to an equation as long as you're adding the same thing to both sides. Well, if you're adding an equation, then you're basically adding two things that are the same. How do we know that negative 7x plus y and 10 are the same? Well, there's this equal sign here telling us they are. So, totally legal. For this next example, we have a different situation. You'll notice that if you try adding these two equations together, nothing good is going to happen. You're going to end up with 11x plus 6y equals 77,500, so nothing cancels. So for two equations where you do not have opposite-like terms that aren't going to cancel when you add them, you can multiply either equation or both by a number that gives you opposite-like terms. So there's a few things going on here. You're basically forcing one equation to have an opposite-like term with respect to the other one. So let's say that you wanted to get rid of the x's, for example, when you add the equations together. Well, to do that, you would need a negative 10x over here. At least that's one way to do it. But you can't just multiply x itself by negative 10. You have to multiply the whole equation by the number because that's just the rules of working with equations. You have to do the same thing to both sides. So if we multiply this first equation by negative 10, that gives us negative 10x, which is what we want, and then whatever else happens kind of just happens. So we have negative 10y equals negative 90,000. And at this point, you'll notice we have those opposite-like terms. So at this point, I'm going to let you pause the video and finish this one on your own. All right, so hopefully you chose to add these equations together, because that was kind of why we did this multiplication. That cancels out the 10x's. For the y's, we have negative 5y on the left side. And on the right side, I'm going to use the calculator. So crunching those numbers on the calculator, that comes out to negative 21,500 on that side. And now I'm going to use the calculator again to divide that by 5, negative 5. So going back to the calculator, divide by negative 5 to get 4,300. So that's my y value. And then plugging that back into this equation over here is probably going to work out a lot nicer. We have x plus 4,300 equals 9,000. And that one I can subtract without a calculator. That's going to be x equals 4,700. So then 4,700 comma 4,300 is our answer on this one. And this is also a good example of how the graphical method doesn't always work so well. This would be a lot tougher to do with a graph. For this last example, we've done a few more things to make it a little bit more difficult. Pause the video and see if you can figure out what's new about this situation. All right, so one thing you might have noticed at the very beginning is that these are not in the same form in terms of equation format. So for this first one, we have an x plus y equals a number sort of thing. For the second equation, we have x equals a number plus y. In order for elimination to work, you really want both equations to be in what I like to call standard form. So that's ax plus by equals c. That way, if they're both in this form, when you add them together, you'll actually be adding the x's and the y's together on the left side and constants on the right. If we were to add these equations together right now, well, you have a y on the left, but the other y is on the right, so those are not going to get combined right away. I mean, you could move things around afterwards, but that's kind of annoying. So let's get this in standard form, this one on the right here. We can do that quickly by just subtracting 5y from both sides. So 4x minus 5y equals 22. And let's move on to the next hurdle for this problem. And that is, if you add these equations together, even in this format, first off, nothing's going to cancel, but we're used to that by now. The big problem, though, is that there's nothing I can multiply just one of these equations by to get opposite-like terms, at least no nice whole numbers. I mean, I guess I could multiply this first equation by like 2.5, but then I'm messing around with fractions or decimals. So one other trick you can use if you don't want to mess with fractions or decimals is you can multiply each equation by a different number. So first off, figure out the variable that you want to get rid of. So for example, let's say we want to get rid of the y's. Look at the coefficients of those variables, 2 and negative 5, and just figure out a number that those both go into. For example, 2 and negative 5, those both go into 10 or negative 10. So what I could do if I want to get rid of y is multiply this first equation here by 5 to get 10y, multiply this other equation by 2 to get negative 10y, and then those will cancel out. Of course, I could do the same thing with the x's. I could multiply this one by 4 to get 12x, multiply this one by negative 3 to get negative 12x, and then I could get the x's to cancel. So you just have to pick a variable and basically try to get the common multiple for both of those. So let me start by doing 5. I'm going to get rid of the y's here. So I'll multiply this first one by 5. That's 15x plus 10y equals 25. And then I'll multiply this one by 2. So that's 8x minus 10y equals 44. And then if I add these together, now I've got those opposite-like terms that are going to cancel. So that's 23x on the left. On the right, I've got 69. Dividing by 23, that's going to be x equals 3. And then the rest is pretty much the same. Just plug that back in. We'll plug it into this equation here. So that's 4 times 3, which is going to give me 12 over there. Subtract that from the 22. I've got negative 5y equals 10. So y equals negative 2. And then my answer, 3 comma negative 2. So just to recap, make sure you have equations in standard form. Feel free to multiply by a different number. Add those opposite-like terms to get them canceled out. Solve for a variable, plug it in to get the other variable. So as you can see, there can be a lot of steps with these elimination problems. In order to help you sort it all out, the following are steps to solve any problem by elimination. So no matter how nasty it gets, if you follow these steps, you will cover all your bases. But they're out of order. Pause the video and then go on your guided notes, number each step to show the proper order. So first step gets a 1, so on and so forth. All right, now looking through this list, the very first thing we need to do is put both equations in standard form. After that, we need to start looking for opposite-like terms. If you don't have them, then you have to multiply one or both equations by a number so that you have exactly opposite-like terms. Then you can add the equations together to get rid of a variable. That will allow you to solve for one of the variables. So that's our next step. And then once you've found one of the variables, you can plug it back in to solve for the other variable. So that's all for elimination. Until next time, this is Mr. Sutton signing off.